Welcome back. Today we are talking about solving multi-step equations. This is very similar to the lesson that we did yesterday with solving one- and two-step equations. What we're going to add in today is combining like terms and the distributive property. So a couple things to keep in mind are the steps to solve that we talked about yesterday. Number one is the golden rule. Whenever you do it to one side, you have to do it to the other. That's the only way you can keep an equation balanced. So we drew a line through the equal sign, we circle variables to isolate, and then we undo the math by filling it back in layers. Some other things that we're going to cover today that we didn't talk about yesterday were combining like terms. A lot of times when you combine like terms, if it's not an equation, it'll just ask you to simplify the problem. That means that you're not going to have an exact, just one numeric answer. You're just going to write it in a simpler form. So it usually starts out as a really long problem and turns into a shorter version of it where you've kind of organized everything together. And then the last thing we're going to talk about today is distributive property. Remember, we talked about what it means to distribute. If you have a distribution center, or if your paper boy distributes your paper or your mail. Distribute is just a fancy word for passing out. Make sure you pay attention to what operation is being passed out. Today we're passing out multiplication because there's a number next to the parentheses without any sign in between. But if there's a symbol there, like a plus sign or a minus sign, in the future, just know that you're going to be passing out that plus or minus, not necessarily a number. Combining like terms look like this. You collect the terms that are together. So you can add A's to A's, you can add X's to X's, you can have numbers to numbers, but you cannot add things that are unlike. It's like we talked about earlier with apples and bananas. If you had a basket full of apples and bananas, you're not going to say you have 3 apples, 2 bananas, and 2 apples. You mention all your apples together. Same thing here. You mention all the A variables together, and then you combine all the numbers together. So 4A plus 2A here in the red shows us that we have 6A. And then the plus 5 and the minus 3 combine together to give us a positive 2. So let's work this one out together. We are going to simplify, and we have 9y plus 3 minus 4x minus 2y minus 3x minus 5. So I'm starting with the y, so you can start with the y, or you can start in alphabetical order and start with the x. It doesn't matter as long as you're keeping the similar terms together. So I have a 9y, and I'm going to go through and circle all of my y's, keeping the number, the coefficient out in front, and the sign together. So I have a minus 2y, and that's all my y's for the problem. So if I have 9y minus 2y, that gives me 7y. Let's move to my x's. I have a minus 4x and a minus 3x. When I combine them together, that gives me a negative 7x. And then I have a plus 3 and a minus 5. That gives me a negative 2. So in simplest forms, this is 7y minus 7x minus 2. Keep in mind that we like to mark each of these. That way we know, looking at our problem, we have dealt with every individual piece. We didn't leave anything out. Alright. Next we're going to talk about distributive property. Make sure you pay attention to the signs. If there's a sign out in front where this A is, that sign has to go with it. So if this was a negative 2, you would be passing a negative out. If this sign right here was a negative, you would need to use the rules for negative numbers. So let's take a look at a couple of examples. I have 5 parentheses x minus 3. Orders of operation tells me to do x minus 3 first, what's inside of parentheses. However, we talked about in combining like terms, I can't do that. So what I'm going to do is I'm going to get rid of these 2 parentheses by distributing the 5. I pass the 5 out to the x, making it 5x, and then I pass the 5 out to the minus 3. We're going to treat that like a negative. 5 times a negative 3 is negative 15. So that is now that simplified with the distributive property. Okay. Next is negative 2 parentheses x minus 5. We are going to distribute or pass out the whole value here of the negative 2. So it's negative 2 times x, which becomes negative 2x. And then negative 2 times negative 5. Remember, a negative times a negative becomes a positive. And 2 times 5 is 10. Next we have kind of like a combo where we have to distribute that negative 3 through to get rid of my parentheses since I can't add that x plus 2. But then I have some other other pieces just hanging out at the end, so we're going to combine those like terms together. So, looking here, I'm going to start with my distributive property because in orders of operations we multiply first before we add and subtract, and combining like terms is just adding and subtracting. So by multiplying, I'm going to pass this negative 3 out to the x, negative 3x. Pass the negative 3 out to this positive 2. A negative times a positive is a negative. Negative 3 times 2 is 6. And then this plus 2x and 8 are not inside of the parentheses, so this negative 3 is not attached to it. They're just hanging out by themselves, so we're just going to bring them down. So this just becomes plus 2x plus 8. Now I can combine my like terms. I have a minus 3x and a positive 2x, which leaves me with just a negative x. Remember, our invisible math, there is a negative 1 in front of there. We do not have to write it, but just keep in mind that anytime you see a letter without a number in front, there is a 1 there. And then I have a negative 6 plus 8. Gives me a positive 2. So simplified, my answer would be negative x plus 2. Alright, now we're going to take that information and solve a couple problems. I have 2x, or 2 parentheses x minus 4 is equal to 22. So when I go in to work that out, I'm going to combine what we talked about today and what we talked about tomorrow. Or yesterday, I'm sorry. So first thing I'm going to do is I'm going to draw a line through my equal sign. Okay? If I add or subtract something to this side, I have to add or subtract that same thing over here. Now, I can't do anything right here, right now, because I have 2 parentheses x minus 4. I can't do x minus 4 because they are unlike terms. They are not the same. So I'm going to distribute and make that a 2x, and then pass my 2 out to that minus 4 and make it 8. Minus 8 is equal to 22. Now, I want to get this x right here all by itself. So I have to get rid of the 2, and I have to get rid of this minus 8. Talking about our layers, we don't want to break this up yet. Okay, these are stuck together. So let's get rid of the things away from that variable first. Let's get rid of this minus 8 to undo minus I plus. If I do it to one side, I do it to the other. That leaves me with a 2x. The 8's cancel out. 22 plus 8 is 30. When I go in and divide both sides by 2, sorry about that, guys. Oh. Technical difficulties. I'm going to divide both of those sides by 2. Those 2's cancel out, leaving me with x is equal to 15. Remember, you can always plug that back in, so it would look like 2 parentheses 15 minus 4 is equal to 22. Do parentheses first. 15 minus 4 is 11, so I have 2 times 11 equals 22. Is that true? Yes, it is. 2 times 11 is 22. 22 is equal to 22. Boom. Okay, here's one of just combining like terms. I have a 2x and a minus 7x, so I'm going to combine those together. 2x minus 7x leaves me a negative 5x. I have just the plus 5 is equal to 15. Draw my line through my equal sign. And you could have drawn your line through your equal sign up here if you'd like. I want to get this x by itself, so I'm going to subtract a 5 from both sides. Leaves me with negative 5x is equal to 10. Divide both of those sides by negative 5 to get that x by itself, because negative 5x means negative 5 times x. So to undo multiplication, I divide, represents a division with a fraction bar. That leaves me with my final answer is x is equal to negative 2. And lastly, we're going to look at a perimeter problem. If you remember, perimeter is just adding up all the sides. And if you remember, these little ticks right here show that each of these sides are the same. So if this side here is 2q minus 3, then this side right here is 2q minus 3, and this side right here is 2q minus 3. So there's two ways you can work this. You can combine your like terms and say 2q, 2q, and 2q is 6q, and minus 3 minus 3 minus 3 is minus 9. Or you could use the distributive property, because when you get into bigger shapes, you're not going to want to keep adding all those together. So I have three sides that are exactly the same. So 3 times 2q minus 3 is equal to, my perimeter is 21, so I know that those should add up to give me 21. When I pass that out, 3 times 2 is 6q. 3 times a negative 3 is minus 9. That's that same 6q minus 9 that we got in the problem just before when I talked about combining like terms. So I'm getting this q by itself. That q is attached to the 6, so we're going to peel back the layer of the 9 first. By adding 9 to both sides, I get 6q is equal to 30. Divide both of those sides by 6, and get q is equal to 5. Make sure that you pay attention to what the question is asking for. This question is asking for what q is, so 5 is my final answer. Sometimes it may want to know what the side length is, and then you would have to go in and plug a 5 in here and say 2 times 5 is 10, 10 minus 3 is 7, and it asks you what one side length is. You can also double check by saying 7 plus 7 plus 7 is 21, making sure your perimeter added up. Alright, hope you enjoyed.